we have P is equal to M out of R squared plus K. Make R the subject of the relation. Now, let's look at the question. This is our R. Okay, but we do not actually have R here. We have R squared. And it is a denominator of M. So what do we do? Okay, we can isolate the M out of R squared first, or we can multiply through by the LCM R squared to make our relation linear. Whichever way or whichever step you decide to take first, you will still arrive at the same answer. Okay, so let's look at this quickly. Is equal to M out of R squared plus K since there's plus K, I rather prefer isolating my M out of R squared. So I move the K to the left hand side of the equation, and since it's positive, it becomes a negative K. So I have P minus K is equal to M out of R squared. I multiply through by the LCM. R squared. So that becomes, remember on the left hand side now we have two terms, P term 1 minus K term 2. So multiply R2 by each term. So R squared, okay, times P minus K. So R squared times P, R squared times minus K. Okay, that's what I have here. All is equal to what? M. Or out of R squared times R squared. And this crosses out. So we have R squared P minus K is equal to M. I want to isolate the R squared, so I divide here by P minus K, also by P minus K. Okay, this crosses out that, and I have what? R squared is equal to M all over P minus K. I'm asked to make R the subject, not R squared. R, but not R squared. So for me to remove the square, then I find the square root of both sides of the equation. So I find the square root of R squared and the square root of M out of P minus K. Okay, and this square root is going to remove the square. Okay, so I have R is equal to square root of M out of P minus K. So this becomes our final answer. Now the next thing we're going to look at is substitution. Okay, we're going to look at substitution. So let's quickly look at such question. A question on substitution. Thank you.